So on number 1, it's obviously a function because you never plug in the same number twice, right? If you had a 3 and then it gave you a -8, then it would be a broken machine, but that's obviously not there. You never plug in the same number twice. So moving on to number 3. Now this one's a relation. This one is a broken machine, right? This is a relation, R. Why? Because the input 4 gave you the output 2, and it also gave you the output 5. That's like plugging in the number 4 and getting out a 2, and plugging in the number 4 again and getting out something totally different, which means the machine's broken. You could even think about this visually, like with coordinates. Like you could think of the coordinate 4, 2. Your input's 4, your output's 2. And you could think of the coordinate 4, 5. Your input's 4, your output's 5. And visually, on an XY plane, 1, 2, 3, 4, 1, 2 is right here. That's 4, 2. And 4, 5 would be up here. So that would definitely fail the vertical line test. The vertical line would have 2 dots on it. So visually it would fail. Numerically it would fail. Plug in a 4, get out 2. Plug in a 4, get out 5. So that's not a function machine, that's a relation. Let's move on to number 5. Number 5, you have to check and see if you ever plug in the same number twice, which you do. There's a 5 here and a 5 there. And they give you 2 totally different outputs. So this machine's broken. That's a relation. Let's move on to number 7. Number 7, all these coordinates, technically it is like an XY table. Just these are your X's, those are your inputs, those are your outputs. In, out, etc. X's or Y's or ins and outs, whatever you want to think of them as. But you never plug in the same number twice. You plug in a 2, plug in a 4, plug in a 3, plug in a 5, plug in a -2. You're plugging all these different values in, so that is a function. If you were to plug in the same number, like let's say you had a -2 and a 6, then that would be a broken machine. That would just be a relation. But that -2, 6 doesn't exist. I just wrote it. So with the original coordinates, yes, it is a function. Number 9 below, some people get confused because all you see is an equation. Above you have coordinates. So if you wanted coordinates, you could go to an XY table. You could make some coordinates, right? Plug in 0, 1, 2. If you plug in a 0, you'll get out a -5. So one coordinate's 0, -5. Another coordinate, if you plug in a 1, 2 times 1 is 2, minus 5, that's -3. If you plug in 2, 2 times 2 is 4, minus 5 is -1. So now you have coordinates, and as you could see, you're never plugging in the same input twice, and you're getting a single output for each input. Even if you were to plug in the number 1 again, well, obviously, if you plugged in the number 1 again right here, it would also give you the same output, -3. So this is a perfectly functional machine. It works, so it is a function machine. As a matter of fact, this is in function form. Function forms means y by itself. So absolutely, it is a function. You would say, yes, it's a function. When we move on to number 11, what you need to do is the vertical line test. And move that vertical line from one side to the other. And if at any point your graph crosses it at 2 or more, at more than 1 point, then it would fail the vertical line test. But as you can see, it passes the vertical line test. So this is definitely a function. Let's move on to number 13. This one does not pass the vertical line test. As you can see, it touches there and there. So the vertical line gets touched twice by this graph. So it's not a function. It fails the vertical line test. It's just a relation. So we put an R right there. For the second half of the worksheet, we're dealing with functions, f of x and g of x. And this is function notation. You simply go to the f of x function because there's an f and plug in 8 wherever the x is at. I first recommend getting your f of x function and rewriting it, but instead of x is putting parentheses. So I would say 3x plus 2. And what goes inside the parentheses? Exactly what's inside of the parentheses here. So put that 8 in there and then do the math. 3 times 8 is 24. 24 plus 2 is 26. That's your final answer for number 15. Let's move on to 17. It's g of 2. Now the g function is x squared minus x. So instead of writing x squared minus x, let's replace the x's with parentheses and say parentheses squared minus parentheses. So this is the g function, x squared minus x, but we replace the x's with parentheses, and then we plug in the value 2. So let's plug in that value of 2 that's in the parentheses right there and put it into the parentheses. 2 right there, 2 right there. And then do PEMDAS. 2 squared is 4. 4 take away 2 is 2. And that is your final answer for 17. Let's move on to 19. G of negative 6. Again, it's saying to go to your g function, which is g of x equals x squared minus x. And what we're going to do is plug in this negative 6. So plug in a negative 6 right there and a negative 6 over here. And you will get, when you do exponents first, negative 6 times negative 6 is positive 36. And then the minus minus 6 changes to plus plus 6. So 36 plus 6, that is 42. And that should be your final answer for 19. Let's move on to 21. So 21 tells us to do f of 1. So we're going to take the 1 and plug it into the f function. Once we work that out and get an answer, then we're going to subtract 1 at the very end. So the f of x function is, f of x is 3x plus 2. And of course, we're going to rewrite it 3x plus 2, but we put parentheses instead of the x. And we are plugging in this inside 1 right in there. And then we do the math. 3 times 1 is 3. 3 plus 2 is 5. But remember, this is just the f of 1 work. We still need to subtract 1. So let's bring down that minus 1. And you're finally going to have 5 take away 1, which equals 4. And we are done with 21. Let's move on to 23. G of negative 1 plus 4. So g of x is x squared minus x. So we're going to rewrite it x squared minus x, but instead of x's I put parentheses. And then I'm going to plug in the negative 1 into the parentheses. Negative 1 there, negative 1 there. And then I'm going to do the math. Negative 1 squared, that's actually positive 1. 1 plus 1 is 2. And that's barely this work for g of negative 1. We still need the plus 4, so we bring that down, plus 4, and 2 plus 4 is 6. And we're done. Oh no, we have 25. G of 3b. So g of x, let me rewrite that. G of x is x squared minus x. So we really have parentheses squared minus parentheses. And inside of the parentheses, we're putting in that 3b. So the question is, what is 3b squared? What is 3b times 3b? 3b times 3b is really 3 times 3 times b, which is 9b squared. And then you bring down the minus 3b. And obviously you cannot combine these terms because they are not alike. You have b squares and b's. You can't combine them. So that's your final answer for number 25. 9b squared minus 3b. We're done with the odds. Make sure you have everything complete.